In today's video, we're looking at question number 8 from page 1117 of our SAT Big Blue books. Let's read it together. The line y equals kx plus 4, where k is a constant, is graphed in the xy plane. If the line contains the point c comma d, where c is not equal to 0 and d is not equal to 0, what is the slope of the line in terms of c and d? So this one's an interesting question. I think it's a pretty difficult question, and it has two worthwhile things to discuss. Firstly, it's a question about lines, and we know that those tend to be a little bit trickier on the SAT. Second, it has a ton of variables. If we list them out, we have y's and x's and k's and c's and d's. Whenever we have a lot of variables like that, and even if we're slightly intimidated, it's always a good idea to try something like plug in or back solve. Here, looking at how the variables are in the answer choices, plug in is probably the right idea. So let's see. Let's start this question with plug in. We notice that each of the answer choices has a c and a d in it. So it might not be a bad idea to plug in a point c comma d. Let's see. I don't want to overthink too much with plug in, so I can just pick any random point. I'll pick 1, 2. I literally just thought of that off the top of my head. Any two numbers should work here. So now what we're saying is, we have a line y equals kx plus 4, where k is a constant, and the line contains the point 1, 2, c comma d. We're looking for the slope of this line. Now remember, when it comes to our typical y equals mx plus b, our slope is our m. So essentially what we're looking for is we're looking for our k. Now this actually shouldn't be too bad. I should have a pretty easy setup for this. Since we have y equals kx plus 4, all I really need to do is substitute the y and x that I made up. Remember, with plugin, I could pick any two random numbers and it should work every time. If I substitute 2 for y, right over there, and 1 for x, right over here, I should be able to solve for what k is. 2 equals k plus 4. K equals -2. Circle that. That's my objective. If you think this is a little bit too hasty, you could try it again with two different numbers and see that it works out exactly the same. You'll get a different k value, but when we plug it into the choices, we should find only one true correct answer. So let's see what happens. We're plugging in c is 1 and d is 2, and we're solving for the objective -2. Let's see which one of those choices gets us there. I'll plug in down here. A is d minus 4 over c. So 2 minus 4 over 1. That's going to give me -2 over 1. Look at that. A totally works. Now, this makes me really happy to see, but I also get a little nervous that one more of these choices will also work. So I do have to try B, C, and D as well, hoping that none of them will give me -2 as well. For choice B, c minus 4 over d, that's 1 minus 4 over 2. That's -3 over 2. That's certainly not equal to -2, my objective. And then choice C, 4 minus d over c, 4 minus 2 over 1. That gives me 2 over 1, which is the positive version of the objective that I like. So C is out as well. Choice D, finally, is 4 minus c over d, 4 minus 1 over 2, which is +3 over 2, which is also not correct. Look at that. It worked out exactly how I was hoping. Choice A is my only correct answer. Plug-in is a really awesome way to tackle this difficult lines question. Remember, when we're dealing with lines, y equals mx plus b is what we want to think about. And when we're dealing with plug-in, the process should be pretty similar every time. Good luck, everyone.